The B-2 Spirit, otherwise known as the stealth bomber, is an aircraft that looks almost otherworldly with its iconic triangular silhouette and sleek, thin profile. It has the extraordinary capability of slipping in and out of enemy skies nearly undetected, carrying a devastating payload deep into hostile territory. But how did this incredible machine come to be, and what makes it so special? Developed during the Cold War, the B-2 was designed to give the United States an unmatched strategic edge. With a price tag that made it the most expensive aircraft ever built, was the investment really worth it? How does this bomber manage to remain virtually invisible to radar? And what are the secrets behind its cutting-edge stealth technology? Stay tuned, we'll find out together. The development of the B-2 Spirit was driven by the need for a bomber capable of evading advanced enemy radar and missile defenses. By the mid-1970s, the U.S. military began to explore stealth technology, aiming to create aircraft that could minimize radar detection. This need arose from the increasing sophistication of Soviet air defenses, which posed significant threats to conventional bombers. In 1975, DARPA, Defense Advanced Research Projects Agency, requested information from aviation firms about creating an aircraft with a reduced radar cross-section. This led to initial explorations and concepts around stealth technology, and the concept of a strategic stealth bomber became more concrete in the late 1970s with the announcement of the Advanced Technology Bomber (ATB) program, which officially began in 1981. This program saw two competing designs, one from Northrop Boeing and another from Lockheed Rockwell. On October 20, 1981, the Northrop design was selected as the winner. Initially, the B-2 was intended to be a high-altitude bomber, but a shift in mission requirements led to its redesign as a low-altitude, terrain-following bomber. This change allowed the aircraft to fly closer to the ground, reducing the likelihood of detection by enemy radar. The B-2 made its first public appearance on November 22, 1988, at Air Force Plant 42 in Palmdale, California. Less than a year later, on July 17, 1989, it completed its first flight. When the aircraft was presented, one thing was clear. With its distinctive flying wing design, it looked like something straight out of a sci-fi movie. Could such a futuristic design really be as effective as it appeared? Its design was heavily influenced by earlier experimental flying wing aircraft developed by Northrop, particularly the YB-35 and YB-49. These prototypes, conceived by Jack Northrop during and after World War II, demonstrated the potential benefits of a flying wing design. This configuration minimizes aerodynamic drag and provides a large internal volume for fuel and payloads, while eliminating the traditional fuselage and tail section. The YB-49 was an advanced iteration of the flying wing concept, featuring jet engines instead of the propellers used in the XB-35. Like the B-2, the YB-49 had a wingspan of 172 feet and a triangular shape. However, it faced significant challenges, including stability issues and technical problems, which ultimately led to its cancellation in the early 1950s. Decades later, the lessons learned from the YB-49 were instrumental in the development of the B-2 Spirit. Advances in fly-by-wire technology and computer modeling allowed engineers to overcome the stability problems that had plagued earlier flying wing designs. This technological evolution made the bomber not only more stable, but also easier to fly, marking a significant improvement over its predecessors. Just a quick moment before we unveil the rest. If you're new here, consider subscribing to this channel. Stay up to date and never miss out on the latest insights. The B-2 is renowned for its advanced stealth technology, which includes several key aspects like its radar cross-section, materials and coatings, and reduction of infrared, acoustic, and visual signatures. Let's go through these features. The radar cross-section, or RCS, measures how detectable an object is by radar. The B-2 Spirit's design minimizes its RCS, making it appear much smaller on radar than it actually is, often as small as a bird or insect. This is achieved through its unique flying wing shape, which lacks vertical stabilizers and other protruding surfaces that typically reflect radar waves back to the source. The aircraft's smooth, curved surfaces are designed to deflect radar waves away from enemy receivers rather than reflecting them back, thus reducing the chance of detection. The B-2's shape is optimized using computer models that predict radar reflections, ensuring that most radar energy is scattered in directions that do not lead back to the radar source. This concept of deflection is a cornerstone of stealth technology, significantly reducing the aircraft's visibility to radar systems. The construction of the bomber involves the use of advanced composite materials and special coatings that absorb and dissipate radar waves. These materials are critical to its stealth capabilities. The aircraft's skin is composed of radar-absorbent materials, or RAM, that reduce its radar signature. These composites are lightweight yet strong, providing both structural integrity and stealth functionality. Additionally, the B-2 is coated with layers of radar-absorbent paint and other coatings that further diminish radar reflections. These coatings are meticulously applied and maintained to ensure the aircraft remains as invisible to radar as possible. They not only absorb radar waves, but also help manage the aircraft's thermal signature by dispersing heat efficiently. Apart from radar stealth, the B-2 incorporates measures to reduce its infrared, acoustic, and visual signatures, making it a multifaceted stealth platform. The engines of the bomber are buried deep within its wing structure, which helps shield the heat they produce from infrared detection. The exhaust from the engines is also cooled before being expelled, significantly reducing the aircraft's thermal footprint. This cooling is achieved through specially designed exhaust nozzles that mix the hot exhaust with cooler ambient air. The aircraft is engineered to operate quietly. Its engines are designed to minimize noise, and the aircraft's aerodynamic shape reduces turbulence and noise created by airflow. This low acoustic signature is crucial for stealth operations, especially during low-altitude flights where enemy forces could potentially hear the bomber. Visually, the B-2's dark, non-reflective paint helps it blend into the night sky, making it harder to spot with the naked eye. Its design also lacks the typical contours and features of traditional aircraft, which can help it avoid visual detection during daytime operations, especially against complex backgrounds like urban landscapes or rugged terrain. Besides its stealth capabilities, the B-2 is one of the most advanced and capable aircraft in the world. Now, let's look at the technology and engineering that make this possible. It has a wingspan of 172 feet, a length of 69 feet, and a height of 17 feet. These dimensions contribute to its unique flying wing configuration, which helps minimize its radar cross-section. The B-2 is operated by 2 pilots, reflecting its advanced avionics and simplified cockpit design compared to earlier bombers. The bomber is powered by 4 General Electric F-118 GE-100 non-afterburning turbofan engines, each producing 17,300 pounds of thrust. This power allows the aircraft to cruise at a high subsonic speed, typically around Mach 0.85, which is approximately 560 miles per hour. The B-2 operates efficiently at altitudes up to 50,000 feet. One of its most impressive features is its range, capable of flying 6,000 nautical miles without refueling and up to 10,000 nautical miles with 1 aerial refueling. This extended range allows the Spirit to reach targets anywhere in the world from its home base, eliminating the need for forward staging bases. Besides aerial refueling, the bomber can also perform hot pit refueling, which allows it to refuel on the ground without shutting down its engines. This capability enhances its operational flexibility and reduces the time it needs to spend on the ground, thus maintaining higher readiness and quicker deployment capabilities. The B-2 is equipped with advanced avionics and onboard systems that enhance its mission capabilities and survivability. It features a highly advanced fly-by-wire flight control system, replacing conventional manual controls with electronic interfaces. This system provides excellent maneuverability and stability, allowing the bomber to perform precise flight operations even in challenging conditions. The avionics suite includes sophisticated navigation and targeting systems, enabling it to operate in all weather conditions, day or night. It is equipped with both GPS and an inertial navigation system, ensuring accurate navigation over long distances. The onboard radar systems are designed to detect and track ground targets while minimizing the risk of detection by enemy radar. Additionally, the B-2 has robust communication systems that allow it to receive real-time updates and relay critical information to command centers and other units. These systems ensure the aircraft can adapt to changing mission requirements and effectively coordinate with other forces during operations. The B-2 can carry a significant payload, with a maximum capacity of 40,000 pounds of both conventional and nuclear weapons. The internal bomb bays are designed to accommodate various munitions, including gravity bombs, precision-guided bombs, and standoff weapons. It can carry up to 8,500-pound class Mark 82 bombs or 16 2,000-pound class Mark 84 bombs. These unguided bombs can be used for general-purpose bombing missions. It can be armed with Joint Direct Attack Munitions, or JDAMs, which are guided by GPS to provide high accuracy. The bomber can carry up to 16 2,000-pound GBU-31 JDAMs or 8,500-pound GBU-38 JDAMs. It can also deploy various standoff weapons that allow it to strike targets from a distance, minimizing the risk to the aircraft. Examples include the AGM-154 Joint Standoff Weapon and the AGM-158 Joint Air-to-Surface Standoff Missile. It is capable of carrying nuclear bombs, such as the B-61 and B-83. The B-61 is a versatile bomb that can be adjusted for different yields, while the B-83 is one of the most powerful nuclear bombs in the U.S. arsenal. Additionally, it can also carry a variety of other munitions, including the CBU-87 Combined Effects munition and the GBU-28 Bunker Buster, designed to penetrate hardened targets. The combination of these munitions allows the B-2 Spirit to conduct a wide range of missions, from strategic nuclear deterrence to precision conventional strikes against high-value targets. Worth mentioning is that the bomber does not have traditional defensive systems like onboard guns or missile countermeasures. Instead, its primary means of defense relies on its advanced stealth capabilities. The focus on stealth over traditional defensive armament is a strategic choice, leveraging the B-2's ability to penetrate deeply into hostile airspace undetected, rather than engaging in direct combat with enemy aircraft or ground-based defenses. The B-2 Spirit has a distinguished operational history that underscores its strategic importance. As mentioned earlier, it took its maiden flight in 1989. But it wasn't until the 1990s that the aircraft began to see active service. The bomber made its combat debut during the Kosovo War in 1999. Over the course of the conflict, it played a pivotal role in NATO's bombing campaign. 6 B-2s flew about 50 sorties, which accounted for only a small fraction of the 34,000 total NATO missions. However, they were highly effective, being responsible for dropping approximately 11% of all ordnance used and striking 33% of the targets within the first 8 weeks. This demonstrated its significant capability and efficiency, despite its limited number of missions. Following its successful deployment in Kosovo, the B-2 Spirit was used in Operation Enduring Freedom in Afghanistan in 2001. The aircraft flew some of the longest missions in history, including a non-stop 44-hour flight from Whiteman Air Force Base in Missouri to Afghanistan. Can you imagine the endurance required for such long missions? Whiteman Air Force Base is the only operational base for the B-2 Spirit, highlighting its centralized deployment strategy. The bomber continued to demonstrate its strategic value during Operation Iraqi Freedom in 2003. Operating from Diego Garcia during the Iraq War, it released over 1.5 million pounds of munitions, underscoring its significant payload capacity. In 2011, the aircraft made a significant impact during Operation Odyssey Dawn, the international military effort to enforce the UN no-fly zone in Libya. Marking a key milestone, 3 B-2 bombers flew from the United States mainland across the Atlantic and delivered 40 bombs on a Libyan airfield. In 2017, they were once again called into action, targeting an ISIS training camp in Libya. During this mission, 2 B-2 bombers dropped 108 500-pound Joint Direct Attack munition bombs. The round-trip flights from US to Libya lasted 34 hours and included 15 in-flight refuelings. This operation underscored its long-range precision strike capabilities. No B-2 Spirit has ever been shot down during a mission, showcasing its effectiveness and stealth capabilities. However, there have been several significant incidents involving the bomber. The most notable incident occurred on February 23, 2008, when the B-2 named Spirit of Kansas crashed shortly after takeoff from Andersen Air Force Base in Guam. This crash was caused by distorted data in the aircraft's air data system, which led to an incorrect angle of attack and subsequent stall. Moisture in the aircraft's port transducer units during air data calibration distorted the information being sent to the bomber's air data system. As a result, the flight control computers calculated an inaccurate airspeed and a negative angle of attack, causing the aircraft to pitch upward 30 degrees during takeoff. Both crew members ejected safely, but the aircraft was destroyed. The loss was significant, estimated at $1.4 billion, making it one of the most expensive aviation accidents in history. Another major incident happened on September 14, 2021, at Whiteman Base in Missouri. A B-2 experienced a landing gear collapse, causing it to skid off the runway. This resulted in significant damage, estimated to cost nearly $10 million. The aircraft had to undergo extensive repairs, further impacting the fleet's readiness. Most recently, in December 2022, another B-2 was damaged during an emergency landing at Whiteman Air Force Base. The incident led to a fire, and although no crew members were injured, the aircraft's damage prompted a safety stand-down for the entire fleet. Recently, in May 2024, the Air Force decided to retire the damaged B-2 instead of repairing it, citing the high cost and long duration of repairs. According to a force structure report published by the Pentagon in April 2024, the aircraft is being retired in the fiscal year 2025 due to ground incident damage deemed uneconomical to repair. The bomber was one of the 21 B-2s built, and the fleet will be reduced to 19. Speaking about costs, this bomber has always been surrounded by significant costs and controversies. From its conception, the B-2 stood out for its exorbitant price, and its production costs soared due to its advanced technology and the complexity of its stealth capabilities. The initial unit cost estimated at $737 million in 1997, over $2 billion each when adjusted for inflation, escalated to $929 million per aircraft when spare parts and software support were included. Such astronomical figures made the B-2 the most expensive military program of its era. This immense investment naturally sparked heated criticism. Detractors questioned its utility after the Cold War, doubting the effectiveness of a nuclear bomber in a changed geopolitical landscape. Furthermore, its vulnerability to next-generation radar and prohibitive maintenance costs, estimated at around $3.4 million per aircraft per month, raised concerns about its practicality. In 1992, President George H.W. Bush even proposed canceling the program, but it was partially salvaged by Congress. In 1995, the Congressional Budget Office noted that purchasing additional B-2s would not generate significant savings in ammunition costs. The following year, Congress ended the acquisition of new aircraft. Originally, the U.S. Congress had planned to purchase 132 B-2 bombers, but decided that the fleet would remain limited to 21 units. The high costs have been a point of contention, particularly in the face of budget constraints and shifting defense priorities. The operational costs of maintaining this fleet are also substantial, with each aircraft requiring meticulous care to maintain its stealth capabilities. The loss of any B-2, as seen in the incidents over the years, represents a significant financial setback given the limited number of these aircraft and their critical role in strategic operations. Adding to the financial debate, in May 2024, the U.S. Air Force awarded Northrop Grumman a contract worth up to $7 billion for continued sustainment and upgrades of the B-2 fleet. This contract, running through 2029, includes enhancements, sustainment efforts, and logistics services to ensure the bomber remains viable and mission-ready. The investment reflects ongoing efforts to keep the aircraft's technology updated and to resolve maintenance and operational challenges, which underscores the continuing high costs associated with its upkeep and modernization. Despite these controversies, the B-2 Spirit continues to serve as a cornerstone of the U.S. strategic bombing capabilities. What does the future hold for an aircraft that has already made such a significant impact? Well, its future is being shaped by both ongoing sustainment efforts and the development of its successor, the B-21 Raider. The B-21 Raider, currently under development by Northrop Grumman, is designed to build upon the capabilities of the B-2 while incorporating the latest advancements in stealth technology, avionics, and materials. The B-21 is expected to offer improved range, payload capacity, and survivability, making it a more versatile and capable platform for future combat scenarios. The introduction of the B-21 will allow the U.S. Air Force to maintain its strategic edge with a fleet of modern, stealthy bombers, capable of penetrating advanced air defenses and delivering precision strikes anywhere in the world. Despite the arrival of the B-21, the B-2 Spirit will continue to play a vital role in the U.S. Air Force for the foreseeable future. The recent billion-dollar sustainment and upgrade contract awarded to Northrop Grumman underscores the commitment to keeping the B-2 operational and effective. The transition to the B-21 Raider will be gradual, allowing for a phased retirement of the B-2 fleet. This approach ensures that there is no gap in the U.S. strategic bombing capabilities, and that the Air Force retains a robust and versatile bomber force. The B-21 will complement the B-2 initially, before eventually taking over its role as the primary long-range strategic bomber.